Okay, in today's discussion, we're going to be looking at percent yield and limiting reactants. So we're going to address the percent yield first. Percent yield is just a measurement of how much product you produced in an experiment compared to how much you could have produced based on the amount of reactants that you started with. Okay, so here's our expression here for calculating percent yield. The thing to remember about this, back here, is that these values that you have here, the fact that they use the word yield, that means that they are going to be products of whatever reaction it is that you're looking at. Okay, so product values are what you're going to use to calculate your percent yield. All right, the actual yield, that is an experimental value, and in working one of these problems, that will either be given to you, or you'll be given a percent yield and be asked to back calculate that. But at any rate, this is not something this is something that would be an experimentally determined amount. The theoretical yield, that is a calculated value, and it's going to be based on the amount of the reactants that you started with. So the theoretical yield would be the most that you could make given the amounts of reactions that you start with. Now, next to the link for this podcast, there is a percent yield worksheet, and we're just going to work through the problem that's on there, so you can just open it up and have it available or print it out, whichever works for you. But, okay, it says that the reaction that we're dealing with is iron 3 phosphate. So we have FePO4, and it's reacting with sodium sulfate. And it says that our products are iron 3 sulfate and sodium phosphate. Okay, so as with anything, we need to balance our reaction. And so let's see, we're going to need on there, going to need a 2 and a 3 and a 2 right there should do it. Okay, question number 2 says if I perform this reaction with 25 grams of the iron 3 sulfate or phosphate, so I have 25 grams here, and an excess of sodium sulfate, then how many grams of iron 3 sulfate can I make? All right, so it's wanting mass of this. Okay, so we need our molar masses for these. Let's see, so we have plus of phosphorus plus 4 oxygens. So I'm getting 150.817 grams per mole. And then for the iron 3 sulfate, plus 3 and 12 oxygens. And so we get 550.697 grams per mole. Okay, that seems really large. Let me double check that one. 2 times 73. Okay, I'm getting a different number now. Yeah. Okay, so I'm getting, let's erase this. A little bit smaller, still a big number, but not quite that big. Okay, 399.88. Hopefully you're working along with me and didn't make the same mistake I made. Okay, so now we have 25 grams of the iron phosphate going to moles. We have 1 mole of iron phosphate, or sorry, 2 moles of iron phosphate to 1 mole of iron sulfate. And back to grams. And that gives us, let's see, divided by 2 times 399.8. Okay, so I'm getting 33.14 grams of the iron sulfate. And that is the most we could make based on using 25 grams of the iron phosphate. So that is our theoretical yield. Okay. In number 3, it says if 18.5 grams of iron are actually made when I do this reaction, what is my percent yield? So here it's giving us an actual of 18.5 grams. And so my percent yield then is going to be 18.5 over 33.14 grams times 100. So I'm getting 18.5 divided by, and about 56% on that. Not a great percent yield, but it would depend on the process as to whether that would be something we would be pleased with or not. Okay, so then looking down, we're going to skip problem 4, go to number 5. It says if I do this reaction with 15 grams of sodium sulfate and I get a 65% yield, how many grams of sodium phosphate will I make? Okay, so I'm going to open another slide here. Let's rewrite our equation. Here we have 2 NaCO4 and 3 Na2 SO4, which gave us Fe2 SO4 3 and 2 Na3P4. Okay, so here it says if I'm going to do the reaction with 15 grams of the sodium sulfate. Okay, and we have 399.88. Let's transfer some data here. All right. And so essentially on this one, let's look at what it's asking us. Essentially here, it's giving us the percent yield, and it's giving us a starting amount, and it wants us to know how much sodium phosphate I will make. So it's asking for, and actually, that means didn't read the question close enough. I don't need that value because I'm not going to be dealing with that. I'm going to be dealing with the sodium phosphate. So I've got 2 new molar masses that I'm going to need, but essentially it's asking me to find the actual yield here. Okay, so let's look at our 22.98. So I'm getting 142 grams per mole, and then plus phosphorus plus 4 oxygens. So I'm getting here 163.9 grams per mole. Okay, so let's just kind of lay out where we're headed. We have percent yield, all right, is actual over theoretical times 100. Okay, and in this problem, it gave us that we had 65%, and it wants us to find the actual. Alright, so that means I need to calculate the theoretical to substitute in there. So 15 grams of the sodium sulfate going to moles. And then we got 3 moles of sodium sulfate to 2 moles of sodium phosphate, and then back to grams. So that's going to give us, let's see, 15 divided by 142 times 2 divided by 3 times 163.9. So I'm getting 11.54 grams of the sodium phosphate. And that is my theoretical. So I'm going to take that value and I'm going to plug it in right there and back calculate then and that gives me an actual value of, let's see, equals that times an actual of 7.5 grams of sodium phosphate. Okay, and that's percent yield.